So far, we've looked at searching through an array using binary search. We've looked at collections.sort, and we've looked at shuffling. Now we're going to look at how to do custom ordering with comparators. So the comparable implementation sorts an array and returns it in a specific order that you can't modify. So for example, if you have an array of strings, and we're calling it strings, and we store military alphabet in it in a random order, and of random capitalization, like foxtrot it begins with an uppercase, and hotel begins with a lowercase, and Charlie begins with an uppercase as well. And lastly, we're going to have delta, which is all uppercase. Just to make our code fit better, we're going to have these on a different line, but it's still part of the same array list. So this is our array, not array list, our array. This is our array. We're going to do arrays.sort. We've done this before, and we're going to have our strings array be sorted, and we're just going to print out our array. So we're going to have to do arrays.toString, otherwise it's going to return the address, and then our array name. Once we print this out, we are going to get Charlie, Delta, Foxtrot, Alpha, Bravo, Echo, Golf, Hotel. Now this is probably different than a specific way that you were asked to sort something. So like if you were asked to sort something in alphabetical order, this would be incorrect because it prioritizes strings with capital letters first and afterwards the lowercase strings. So to do this, we need to change our arrays.sort. We can do this by leaving the strings. We need to leave the array, the name of the array that we are trying to manipulate. Put a comma and do string dot case insensitive order, the first one. And what this does, it's a comparator that orders string objects as by compare to ignore case. So it's not going to care about what the case is for the strings. It's just going to run it in order. And that order will be like this. If we need to create our own comparator method, we could do something like this. We're going to make a new method. It's going to be public. It's going to have interface, comparator, and then T. This is what it's going to look at. Like, this is the syntax of it. And we are going to have a public int compare. So whatever we are comparing is going to be inside of here. And then we are going to have the T01 and T02. Like this. And this comparator, so this comparator method is like implementing the comparable interface, except that instead of placing the code inside the class to be compared, you write your code in a separate comparator class. And the compare method is similar to the compare2 method from the comparable interface, except that it accepts both of the objects to compare as parameters. The compare2 method accepts only one object as a parameter because the other object compared is the implicit parameter. Like comparable, comparator, what we have here is actually a generic interface that requires you to specify the type of objects you'll be comparing. For example, if you wish to write a comparison function for strings, you must write a class that implements comparator strings. So instead of this T, it'll be string. The reason why we don't use this comparator in our ordering right here is because this string.case insensitive order is already part of Java's library. If a certain comparing is not in Java's library, we have to create it on our own. But since this is in Java's library, we were able to use it to get our output to look like this. Now we are going to write a comparator that orders strings by their length. Our method should return a negative number if the first string is shorter than the second, 0 if they are equal in length, and a positive number if the first string is shorter than the second. Since it's not in the Java library, we need to make our own class of this, not a method, but a class. So we are going to make a new class in our package for Eclipse, and we're going to call it length, comparator. So this is what we have, and we're going to say that it implements comparator and string. So it's going to implement the comparator, and we can import this with our java.util. So it looks like this, and it's type string. Inside of here, we need to have a method, public int compare. Since it's returning an integer, we need to make it public, and the name of it is compare. It's going to take two parameters, string s1 and string s2, and we have brackets surrounding it, and we're just going to return s1.length minus s2.length. And we, like we said earlier, if our first string is shorter than the second, it will return a negative number. This is true because if our first string is 1, our second is 2, it'll be a negative 1. If they're both the same length, they'll both subtract from each other and it'll be 0. And if the first string is greater than the second, it's going to be positive. From here, we can go back into our other code. We can put these on top of each other so we can compare. We can go back into our regular code, and this is what we have. This is what we're looking at. This other method did not interfere with it, so this is all we're looking at. Now, if we sort by alphabet, we use this. Since we're not sorting by alphabet, we can comment this out, and we can write that we're sorting by length. And with sorting by length, we are going to do arrays dot sort like normal, and we are going to have to put our array name in, which is strings, comma, what we're doing, which is new. We're making a new length comparator. And since it is a class, we have to have our parentheses, and that is how that works. This is going to call this class, and when we run it, it is going to output like this. So the output is based on length of the strings, still in somewhat of an alphabetical order. If they're the same length, it's going to be in alphabetical order, but otherwise it is in length. If we run through this, we can basically see that this class is comparing two strings, right? We have this compare method that takes in two strings. So if we have, let's say, foxtrot and alpha, if our string 1 is foxtrot and our second is alpha, it's going to be s1.length minus s2.length. Since s1 is greater, it's going to return that s1 has a bigger length, which means it'll go farther down our list, and it's going to continue to do that for the rest of them.